What is piling? Why is it necessary? And where do we use it? Here's a brief description explaining it. First, let us start with the most commonly used foundation types: rubble foundations, isolated footings, strip footings, raft foundation. When the number of stories increase, the load transfer to the ground also increase. The foundation should be able to withstand that kind of load and pressure. Therefore, stronger foundation types should be used. Building 2-story or more isolated footings are needed. When the number of stories are increased further, raft foundations and strip footings can be used. These foundation types cannot be used when building high-rise buildings, since their design loads are quite high, and in this case the load should be transferred to deep stable layers of the ground. This is why we use the method called pile foundation.
Pile foundations can be classified as displacement piles and replacement piles. Displacement piling is a hammering process, as you can see here. In this process, the pile is precasted and hammered to the ground. At the present, displacement piling has been abandoned by the contractors as it has few disadvantages such as high sound and vibration effects. Therefore, nowadays piling contractors use replacement piling instead of displacement piling. Replacement piling is totally different as the soil is removed by machinery and pile is concreted at the site.
There are few advantages of replacement piles over displacement piles, such as low noise and vibrations during installation, ability to penetrate boulders, possibility to identify subsurface layer conditions, and to install larger diameter piles and etc. This replacement piling is often defined as cast in situ board piling. These are the main procedures of cast in situ board piling: casing installation, drilling operation, reinforcement cage installation, pile concreting, finally casing removal. The first task is setting out the pile location. Then offsets should be laid on the ground to guide the casing in the correct point. Then the soil is removed by the BG machine. After that, installation should be done carefully, such as checking the offsets and verticality of casing. Then the casing is driven to the ground. The primary function of the casing is to prevent collapsing of the loose soil at the ground surface. It also guides the drilling tools. Soon after the casing is installed, the casing should be filled with the drilling fluid called bentonite. Bentonite is a special clay that can swell and gel once it is dispersed. Bentonite supports the excavation by exerting hydrostatic pressure on the walls of the drilling hole. It remains in excavation and do not flow to any great extent into the soil. Further, it can be used after separating sand by the use of separators called descenders. Bentonite properties such as density, viscosity should be checked.
When the piling operation is going on, properties of bentonite should be checked time to time. Viscosity is one of the major properties of bentonite which directly affects the circulation of bentonite. Marsh cone method is used to check the viscosity of bentonite. Firstly, the bentonite should be poured into the cone by blocking the bottom of the funnel by a finger. Then the cup is filled by bentonite up to 1000 milliliters up to the mark. And the time is measured to fill up to the level. Viscosity of bentonite should be between 30 to 90 seconds. The density of bentonite is measured by using mud balance apparatus. Bentonite is filled into the cup and the surface of the cup is cleaned properly. Then the arm with the cup is placed on the balance. The counterweight of the arm is changed until the bubble of the arm comes to the center, and when the bubble is at the center, the density should be recorded. Standard bentonite density values vary from 1.1 to 1.25 grams per millimeter. The sand content test is another important test which is used to check the properties of bentonite. Then the bentonite is poured into the apparatus until it reaches the end of the conical shape. The sand content apparatus is filled with water and shaken well. Then the water is passed through the net of the apparatus and sand is collected. Then the net is washed by water into the apparatus. Finally, the sand content can be observed.
The drilling process should be done using different tools according to nature of ground layers. Soil auger and soil buckets are the tools that should be used in soil layers. Rock auger and rock buckets are the tools used in rock layers. For more harder rock, core barrels with roller bits are used. In the drilling process, soil particles and rock particles in the drilling hole are collected into the bucket and removed from the drilling hole. After drilling, the required depth pile bottom is cleaned using cleaning bucket. The next big mission is concreting. Prior to concreting, few tasks should be done. First, the reinforced cage should be fabricated. It should be done while the drilling operations is going on. Before inserting the reinforcement cage, pile should be washed by circulating bentonite. Then reinforcement cage installation should be carried out by using the crane or the BG machine. Laps should be properly welded. Then the concreting should be done. For that, trimmy pipes are used. At the top of the trimmy pipe, the funnel should be attached. Then concrete is poured into the funnel and it flows to the bottom of the pile using trimmy pipes. When the concrete is filled up to a certain level, trimmings can be shortened by removing trimmings from joints. It is better to check whether the bottom of the trimming is under the concrete top level. After concreting, the casing should be removed vertically.
Concrete, which is used for pile concreting, must be tested for their strengths. Before the concrete is poured into the pile, a sample of concrete should be taken to the wheelbarrow. Then the slump test is performed. Normally, the slump and the flow values should be high in the concrete, which is used for pile concreting. The typical value for the slump is between 180 to 220 millimeters. Concrete cube test is performed to check the strength of the concrete. Firstly, cubes are casted in standard molds. Then, after they get hardened, the molds are removed carefully and they are cured by putting into a curing test. The concrete cubes are crushed at the 7th day and the 28th day from the casted day. The strength of the cube should be exceeded the required strength of the concrete. After casting, piles are tested to check whether they can function properly.
The maintain load test, which is known as MLT, is the most expensive and time-consuming test in the piling work. For that, surface near the pile should be improved so that it bears the surcharge weights of the concrete cubes. Then the jack is fixed over the center of the pile and the main beam is kept over the jack. Next, sub-beams are kept over the main beam, and finally the load cell is fixed between the jack and the main beam, while fixing the dial gauges to the pile. Then the pile is jacked and loaded gradually until it reaches 1.5 times of the working load. Then the settlement is measured. The gross settlement of the pile should be less than 25 mm, and after unloading, the net settlement of the pile should be less than 12 mm.
The PDA test is one of the important tests that is carried out to check the load-bearing capacity of piles. Firstly, the pile should be hacked until it reaches the sound concrete and built up to the required level. After the concrete has gained the required strength, the PDA test is performed. Firstly, the cushion surface is prepared on the pile by keeping plywood or steel sheets on the pile surface, and drop weights are placed. Then the loading frame is fixed over the pile. Then the casing is cut from 4 places by keeping equal gaps between cuts. Then the sensors of the analyzer are fixed to the pile. Then the load is lifted along the frame to the required heights and dropped onto the pile by giving a big impact. When the drop weight hits the surface of the pile, a big force is transferred by the drop weight and the velocity of it. Hence, the stress waves are generated and transferred to the bottom of the pile. The load is calculated by the accelerometer and the strain gauge, and finally the readings will be used to analyze the pile capacity.
The sonic caliper test is performed after washing the pile shaft. Firstly, the winch unit has placed on the center of the pile shaft, and then sensor unit is moved downwards to the pile shaft with a speed of 4 meters per minute. The sensor unit emits and receives the ultrasonic waves while moving downwards and records the waves beginning at the time when the sensor unit emits the signal. The depth and the verticality of the pile shaft are recorded using digital encoder. Pile integrity test, which is known as PIT test, is one of the most simplest pile testing methods, which uses the measurement of the sound wave propagation time in a pile. The small hammer gives the impact to the sound concrete of the pile top, and accelerometer measures the response of the reflecting wave. Pile defects such as necking, bulging, and soft toe can be identified easily by the PIT test. Crosshole sonic logging test is used to check the pile integrity. 4 GI tubes filled with water should be installed with a reinforcement cage prior concreting. After the pile reaches required strength, the pile is tested for integrity. The emitter and the collector probes are lowered along the tube until it reaches the bottom of the pile. Then the probes are lifted gradually while transmitting the signal which measures the speed of the wave through concrete. Finally, the waterfall diagram on the computer shows the integrity of the pile. Piles are not only used for building structures, but also for retaining walls. Using piles, it is possible to build walls, which is known as contiguous and secant pile walls. When the distance between piles are 0 or more, they are called contiguous. If the piles are intersected with each other, they are called secant. For secant piles, double wall casings with cutting shoe are required. The diaphragm walls are a kind of retaining walls which can be laid more than 200 meters deep into the ground. Trench cutters and grabbers, which are similar to BG machines, can be used for diagram walls.
Here we have come to the end of our brief description. Hope you have a clear idea about what piling is now. Thank you very much for your time and listening to the presentation.